So you learned how to do limits, right? We did a lot of limits with the graphs. You looked at the tables, got all different methods. So now we get to talk about properties. What are you allowed to do with limits? What are you not allowed to do with limits? Okay, so this first page is a lot of talking because it's just kind of going through them real quick. But, okay, so the constant rule says the limit as c approaches k, or limit as x approaches c of k is equal to k. Okay, that's just saying if k, and keep in mind k is a number. Okay, so that's saying if you have, if I sketch a graph in here, okay, so there's y equals k. Y equals a number, it's a horizontal line, yes? So this is just saying that the limit of k is equal to k, because if you're on here, this whole line is k, you're always approaching the y value of k, because you're on that horizontal line. That's all it's saying. And the key is to just realize if it's the limit of a number, it's going to equal that number. Okay. Identity rule, the limit as x approaches c of x is equal to c. Gosh, excuse me. It's almost like you can just plug that number right in there. Okay. And this would have to do with, you guys remember your perfect diagonal line? Y equals x. If it's on that perfect diagonal line, you plug in 2, you're going to get 2 out. You approach 3, you're going to get the y value of 3, so on and so forth. Okay, but again, these are just rules that will speed things up. The coefficient rule. Notice up here, b and c are real numbers. So this is just saying if you have a number times a function, that number there can be pulled out front, and then you don't have it confusing you in the function, and you'll use it when you work the example. Okay, like you'll use it after the fact. We're going to talk about, we'll practice these on the next page, okay? The sum or difference rule. If you have two things added or subtracted together within a limit, you can separate them and do them individually, because sometimes smaller pieces are easier to work with. Product rule, same thing. If you have two pieces being multiplied inside a limit, you can separate them into limit times limit. Quotient rule, same idea. If you have a division within a limit, it can be a limit divided by limit as long as the denominator is not 0. Okay. A power on the function can also be pulled out and be a power on the limit. Okay, the composite function rule. So this is like kind of like your Fogg and Goff stuff, you remember? Like f of g of x, g of f of x. This is saying if you have the limit of f of g of x, you can pull the f out, and then you're doing the limit on just g of x and plugging that into f. And again, we'll do examples. Similar with the root rule. If you have some type of square root, cube root, whatever, in a limit, and it's on the whole limit, you can pull it and put it outside of the limit. Okay? So, using these will help them make sense. That's what it really comes down to, is just practicing. So, let's go to the next page and practice. Now, we'll see if I can fit all in everything I need to, but okay, so example 1, they ask us to use the properties of limits to find each of the following limits. If a limit does not exist, we're going to state why. And notice, pay attention, they give us a graph of f, and they give us a graph of g. So we're getting ready to practice more limits here. Now, the limit as x approaches 3 from the right of f of x plus g of x. Well, what property applies here? If there's adding within a limit, you can separate it into two limits. So the concept to think about here is the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. That's how your brain can think of this. And it's not even that you necessarily have to rewrite it out like that, like once you know what you're doing. But that's what really your brain can just think as, okay, it's the limit of f plus the limit of g. Now, grab your answers from the graph. The limit as x approaches 3 from the right of f of x. You guys with them?
Yeah.
Right there, yes? Plus the limit as x approaches 3 from the right of g of x. Are you there? And challenging math, 6 plus 8 is 14. That's the answer. Are we okay with that?
Yeah.
I notice the first one was F, the second one was G.
Wait, how'd you get 8 on the second one?
Okay, so first of all, you're looking at graph G.
Oh, I was thinking.
There we go. Okay, that's why I kind of had I was getting ready to ask you if you were with me because I could tell he was.
Yeah.
You good?
Yep.
Okay. No, I was getting ready to call you out and say, where are we? What's wrong? Okay, on B. First of all, I see two limits being subtracted, yes? So we can separate those into two limits. The other piece I see, there's coefficients of 3 and 2. So as we pull those pieces apart to subtract the two limits, we can also put the coefficients out front of each limit. Does that make sense? So when I rewrite this, I'm going to say 3 times the limit as x approaches 5 of f of x minus, we can do the same thing over here, 2 times the limit as x approaches 5 of g of x. Okay, with the property there. Okay, well, I got 3 times the limit as x approaches 5 of f of x.
Maybe 6 times 3. Oh wait, no. It'd be 5. 2 times 3 is 76.
Oh. Okay, so the limit as x approaches 5 is 2, because from both ways you're approaching that point right there, yes? So that is 2 minus 2 times the limit as x approaches 5 on g of x. We're approaching that point right there, yes? And it approaches the same from both ways. So 4. 3 times 2 minus 2 times 4 is going to be? Negative 2. Okay. C, I feel like they should have given us this one before the last one, but it's two limits being subtracted, yes? So officially you can think the limit as x approaches negative 5 from the left of f of x minus the limit as x approaches negative 5 from the right of g of x. Negative 5 from the left on f. 3. Minus negative 5 from the right. No, why did I? That's supposed to be the left again, isn't it? Whoops. I'm like, wait, we couldn't have changed. Okay. Negative 5 from the left on G. Where are we at?
Negative 3.
No?
Let's see.
4.
Because where is the graph approaching? And it is approaching 4. Now, if we ask what is the value of the graph at that point, then we'd say negative 3. but the limit is where the piece is connected and approaching. Okay? And 3 minus 4 is -1. Okay. D, division within a limit can be rewritten as two limits being divided. That 3 on the top, that's 3 times f of x, so I can say 3 times the limit. I don't like how I did this. 3 times the limit as x approaches -7 of f of x divided by the limit as x approaches -7 of g of x. So on top I know there's a 3. The limit as x approaches -7 on f of x.
5.
I'm going to go for 5. After I traced my line because I honestly couldn't tell who was right there.
I looked at 4. Or 6. I don't know.
As I said, that's why I traced because I'm like, eh. Okay, limit as x approaches -7 on g. 3 times 5 divided by 3 is 5. Or, my brain said cancel the 3s and I'm left with 5. Okay. E. What can we do here? Got two limits being multiplied, or multiplication within a limit.
Take them out.
So take them out, make them two limits being multiplied, and the 4 can also be pulled out front, can't it? So we're going to have 4 times the limit times the limit. 4 times the limit as x approaches 3 of f of x times the limit as x approaches 3 of g of x. Okay, I got the first answer, 4.
Why wouldn't it?
Wait,
Why wouldn't you put 4?
Yeah.
It's just multiplication, so there's no distributing.
Okay.
If it was adding,
What?
you could distribute.
They wouldn't both be times 4 then?
It's the difference between, say,
Oh, I
4
see.
times 2 times 3 versus 4 times 2 plus 3.
I got
We can distribute this 4, but that's a no-no. Okay? Okay. Limit as x approaches 3
you. 6.
on f, he says is 6. I'll go with it. Limit as x approaches 3 on g.
It does not exist.
That one's more.
Wait a second. Can't do it.
It's the limit. And for a limit to exist, the limit from the left
That's not.
has to equal the limit from the right. There's a function value there, but that's not what I'm asking. I need the limit value. That limit does not exist. Well, 4 times 6 times a limit that does not exist is just
Does not exist.
does not exist.
So it's kind of like a 0. Like if you're multiple. If it doesn't exist.
Yeah, or really what I would say is the limit of g of x, I can't do that, so I can't do this whole problem because that's a necessary part of the problem. So it's kind of like, had I realized that up front, I wouldn't have even done the rest of the problem, you know. Okay, F. A limit where the function is squared. Keep in mind that means we can just do the limit as x approaches -3 of f of x, and then we can square it. So limit as x approaches -3 on F. Okay, I'm there. So, final answer?
36.
Negative 6 squared is 36. And what's that mean about G? You're doing a square root. Oh, crud. Hold on. You're doing a square root, but what else should I have done?
We messed up.
There's an 8 there,
Take
isn't
the
there?
8 out.
Yeah. So, interesting. My notes I wrote to the power of 1/2.
What?
I'm not sure why I threw that in, but remember a square root is the same thing as a power of 1/2? Like power of 1/3 is a cube root. 1/4, power of 1/4. Like that's necessary information we'll come back to, right? It's a square, yeah, and a cube root, yeah. So I guess square root of 8 times the limit as x approaches 4 of g of x. So, I know there's going to be a square root. I know there's going to be an 8. Limit as x approaches 4 on g. Square root of 8 times 5. Square root of 40. For review, what else is that?
2 square root of 10.
Because 4 is a perfect square, yes? Not that we had to go that far, but on the flip side, I need to review some basic math facts with you. That's been a minute, right? So, okay, H. Limit of f plus g as x approaches -3. I'm assuming you guys seem to be okay. I'm not going too fast, am I? You're probably happy I'm going faster for a change. Because I don't tend to go very fast usually. Okay, the limit as x approaches -3 on f. -6, we just did that actually on the problem above it. Limit as x approaches -3 of g.
Can't do it.
Well, I've got one going down here and one going up, so they're not going the same direction. Besides the fact they don't approach a real number, so that limit doesn't exist, so that sum does not exist.
If one was approaching infinity, would it just be does not exist?
If, say what again?
If like one of the limits is approaching infinity, would the problem just be does not exist?
Oh, like if this had ended up being infinity here? Like, so if they were both going up?
Yeah.
Well, technically, -6 plus infinity is still infinity. Because the idea of infinity is it's not a specific number, it's the idea of going on forever. And so you're approaching, getting larger, larger, larger. You subtract 6, you're still getting larger, larger, larger. So I don't know. I honestly don't know. I don't usually see an answer like that. I'm not sure if you'd just say infinity or if you'd say what Augie said, infinity -6. Like, Okay. 2 more. Division. So limit as x approaches 6 of f divided by the limit as x approaches 6 of g. I need to mix things up. They keep doing f and g, then g. Okay, limit as x approaches 6. Right there, 0. It approaches from both ways, yes, so 0. Divided by the limit as x approaches 6 on g. both approach 5 there. And what does 0 divide by 5? 0. 0 is a number, yes. So 0 is an answer. Okay. I kind of hate that they only put one of these, but function composition. It's f of g of x.
Oh boy.
So,
Oh boy.
but this you won't mind this one. Okay, so all we're going to do is we're going to put the f out front. We're going to say f of the limit as x approaches -2 of g. Okay? Now, that means the f is still going to be outside for right now. We just need to find that limit to put inside. So what's the limit as x approaches -2 on g?
Negative. Oh wait, no.
3.
I lied. 3. Yeah. -3.
-3. Change.
Is it -3?
See,
I'm just struggling with figuring out. Yeah, I have -3 on my paper, I guess. Okay. So now, what's f of -3?
Oh.
oh,
-6.
no.
So f of -3, so go to f on the graph. What is the y value when x is -3? And that is -6. Okay. We'll see. Where are we at? 12:17? I may hit and skip around because I feel like some of this gets very repetitive.
Yeah. Amen.
I mean, that whole page, now I wanted to do that because we kind of need to go through all the different properties. But as I look at this, okay, it doesn't look like it, but we're doing the exact same thing we just did.
Just different.
The difference is these are actually going to be easier. We don't have graphs to look at. What do they tell us in the directions?
Just give us the number.
When x approaches c on f, it's 3. On g, it's -2. On h, it's 4. Okay? Now, if we want to be official, it's writing out all the, it's breaking down the properties. Okay? Which I'm going to at least do a little bit. Now, a square root can go outside of everything. It can also be written as a power of 1/2. Okay? So, like, if I just throw that in, not saying you have to do this, but it's a power of 1/2. And then you're going to have inside that 3 times the limit minus 2 times the limit. Okay, there's an official rewrite. Are we okay with that? Okay, so it's 3 times the limit of h minus 2 times the limit of g, and it's going to be the whole thing, the square root of the whole thing. I wrote it as 1/2, just to be different. So, 3, what's the limit as x approaches c of h? Nope.
Oh, H. Sorry. F. 4.
4. Minus 2 times limit as x approaches c of g,
G is
-2. All raised to the 1/2. So what do we got here?
square root.
I kept writing and quit talking, but I agree with Tate's mumblings there. You guys good? 12 minus -4, so 12 plus 4, 16. 16 to the 1/2. It's the same thing as saying square root of 16, yes? Okay. let's jump. I'm trying to jump because I don't feel like I need to spend a whole nother day on this lesson when we're going to jump down to E. Now, here's a mine. Here's the thing. If you want to check some of these, if you want to do some of these, the answers are in the notes, right? Which will be on Schoolage. Or I can tell them real quick. Let's jump down to E real quick. I'm picking E because it's a little bit different than some of these others. The limit as x approaches C of h of x times, and what's it times? F of x plus 6. So realize there is kind of a distributive thing happening here, although I'm not actually going to distribute because I'm just going to do the math. But, how do I write this? Okay, we pull that, it's h of x times this. So it's the limit as h of x approaches C of h of x. And then it's going to be times, and we've got to do the limit of f of x plus the limit of 6. So the limit as x approaches C of f of x plus the limit as x approaches C of 6. Okay. What's the limit as x approaches C on h of x? 4. Times limit as x approaches C on f of x? Plus limit as x approaches C of 6. Okay, this is our, not identity, it's that very first property.
Oh.
Constant. Anytime you have a constant, a number, it's just that number. So the limit of 6 is 6. Did you do the wrong math? Or did I do the wrong math?
No, I was.
Okay. Let's get fancy. Let's go down to example 3. Again, I'm just hopping and skipping around because, okay. Given, the limit of f is 8, the limit of g is -4. Find the following. Why did I pick this one?
Because it's a lot.
Because it looks overwhelming, right? It's a lot. That's your words. It looks overwhelming. Is it?
We will find out.
No. Okay. So, it's like a big bad use all your properties at once thing. Okay. So, we've got pieces being multiplied, so the first limit, we've got f times g. Remember, that could be two limits being multiplied, yes? The limit of f has a 2, so we're going to put 2 times the limit of f times the limit of g. And then we've got a minus. Well, it's basically two pieces being subtracted, or, well, actually there's a minus and a plus, right? So now, anytime you've got adding and subtracting within a limit, you can separate it into pieces. What do you know about a cube root? You could write it as, if you want, the cube root of the limit as x approaches c of f of x. Or you can write a 1/3 power plus, and on that last one, you've got the 2 out front and the limit squared. So 2 times the limit as x approaches c of g of x, and that whole limit is squared. Okay, plug and chug. You're not caught up with me, right? You're like, I'm not ready to plug and chug. So, 2. What's the limit of f?
8.
8 times limit of g.
-4.
minus the cube root of the limit of f, cube root of 8, plus 2 times the limit of g squared. Okay. Please excuse my dear Aunt Sally. Do all your multiplication properties before you do add and subtract. So
How'd you get negative?
That's all I'm saying.
16.
the cube root of 8.
It's -2.
Because it's subtracting.
Well, the cube root of 8 is 2. Because cube root of something.
Well, I was doing something else.
So cube root of 8 means I need 3 of something, right? So 2 times 2 times 2. So the cube root of 8 is 2. That's part of what we forgot. So multiplying 2 times 8 times -4 was my -64. Cube root of 8 is 2. And over here, squared then multiplied. -4 squared is 16. 16 times 2 is 32. Now, you don't want to hear what's about ready to come out of my mouth next, but I just did that without a calculator. We should be doing that without a calculator.
Tate.
Okay, I was just checking my math.
No. And here's the deal. It's not a huge deal, okay? But this is something that you need to be, I know you can all do this without a calculator. It's whether you want to is a different story. But here's the deal. On AP, you'll be forced to do this kind of stuff without calculator points. We need to practice as we go. Okay? I think there's usually, I haven't even thought about quizzes and tests yet. There's usually some early quizzes and tests that I make no calculator also. Okay, real quick. Are we okay with that in the end, though?
Isn't that
Yeah.
Once you,
98?
no, it's a plus 32.
Oh, yeah.
Because, so a -64 and -2 is -66. -66 plus 32 means I'm going to have to subtract them and use a sign of the larger number. So 66 minus 32 is 34. Because my larger number was negative, it's -34. You see, it's those little things that, oh my gosh, we can't just rely on the calculator. I know.
Do you guys remember the rap song that Miss Pace played when we were learning that?
Oh no.
What?
No?
Like
It
a rap
still-
song
it still
for-
plays in my head for how to determine the signs.
Interesting.
Same signs add different signs subtract, keep the larger.
Okay.
And then the whole
Didn't
thing.
you recite pi in someone's class?
Yeah, I know almost the first 58 digits.
Okay, real quick.
50's a lot.
Yeah.
So on this back side,
Quite,
I probably should have skipped a little bit more to get here. I'm looking to see where it's better to look at, but I'm not sure that it really matters. If we look at something like A or B here, okay, find these following limits. Well, realize here, okay, we've got this. That's what we're trying to find. It's f of g of x. What did I show earlier? This can be f of the limit as x approaches 2 of g of x. Are you okay with that rewrite? Now inside, that means we need to do this limit. Well, limit of g of x. I don't have a graph to look at, but here's the deal. What do you know about g of x equals -2x? So think the graph, y equals -2x. That's y equals -2x is going to be a line, which means on a line is continuous, yes? no matter where you're looking at the limit, it's going to be approaching the same place from both sides, which means the shortcut here is we can just figure out what is g of 2. And that's because the graph is continuous. Okay, if it's a graph where the equation is just continuous, you can just plug the number in to find the limit, as long as it's continuous. I know negative 2x, it's a line. So that means when I plug in negative 2, I'm going to get negative 4. Are we okay with that?
So then you just plug -4.
Now I'm no longer doing a limit, am I? Now it's just f of negative 4, so you're doing negative 4 cubed minus negative 4 squared plus 4 times negative 4 minus 1. Negative 64 minus 16 minus 16 minus 1. My brain says negative 64 minus 32 minus 1. Yeah. Now, and I'm going extra quick. I'm going extra quick, but.
How do we plug 2 in?
Just plugging 2 in for x.
So when you know that.
Wait, which place are we talking about how to?
Like you plug 2 in to
Oh.
get negative 4?
Yes, because so I plugged it into right here. So because this is a continuous graph, because it's just a line. Okay, here's the deal. A line, it'd be a negative line, wouldn't it? So the line's going to look like this. Well, say 2 is right here. My graph is just, the limit is just going to be whatever the value is at 2. Does that make sense a little bit?
So then why did you choose -2? Like why did you multiply -2 times 2?
Because g of x says negative 2x. The equation there is negative 2x.
And then you took
the limit is x to 2.
It was the limit as x approaches 2, so that's why I plugged 2 in. The equation is negative 2x.
Oh,
The
so you put
equation for g.
-2 times the 2.
The limit.
The limit is 2.
Yes.
Okay, so you didn't just make it.
took the negative.
No, I did not make it up.
I really
Sorry.
made it up. I was like, okay, Miss.
No. Okay, this 2 right here is this 2 right here, which is this 2 right here.
I understand now.
No, I didn't realize I'd lost you guys there. I am so sorry. I did not realize I'd lost you guys there.
Just make it
I
up.
didn't see it first.
I was like, whatever you say. Miss.
Okay.
My bad.
Okay, you're not going to like me, but I'm still going to say
Do the homework.
do the homework.
No.
Can't be doing that.
Okay, there'll be times where it may take 2, it may take 2 days and stuff. But some of these early ones, I've got to keep us moving. You don't want to get us in a spot where we're out of time at Christmas, and I still have to give the first semester final exam. So,
Mr. Summers ran out of time in A-Push last year, and he was like going through a chapter a day.
okay, do you can with the homework. We'll deal with questions on Monday and whatnot, and go from there.
Yeah, you can wait.